Okay, good afternoon. I'm Paul Ellsmore. I'm from the Offshore Renewable Energy Catapult, based in Glasgow, but we also have an office down in Blyth in northeast England, just north of Newcastle. I'll try and keep this really short today. So first of all, I'll tell you about catapults in general. You may not know what they are. I'll give you a bit of an overview of how ORE Catapult works. Then I'll give you 3 case studies. We don't actually do a lot down in Wales at the moment, and we want that to change. So I'd like to give you an idea of the kind of projects that we can do with people, but these are not exclusive examples at all. So the first one's our Marine Farm Accelerator, a programme run by Crown Estate, where we fund the Secretariat, a particular project based around one of our pieces of test kit down in Narek, and a non-technical project on supply chain. So I'm going to have to read some of this off. I wouldn't normally read it off, but I don't think you'll be able to read it off the screen. There are 7 catapults operating at the moment. Cell Therapy Catapult, Connected Digital Economy Catapult, that's actually an old slide. They've rebranded themselves as just Digital Catapult. Future Cities Catapult, High Value Manufacturing Catapult, the oldest of the lot, made up of 7 existing technical centres around various universities. There's ourselves Offshore Renewable Energy Catapult, Satellite Applications Catapult, Transport Systems Catapult, and we were all set up by TSB back in the day, Innovate UK now, and the idea being to, we were originally going to be called Technology Accelerator Centres, the idea being that we will help more effectively commercialise innovations coming out of universities, other RTOs and innovative companies. There are 2 more catapults coming online this year, one of which is the Energy Systems Catapult, which I believe was mentioned in the budget yesterday, is now going to be based in Birmingham. There'll be a lot of synergies between our catapult and the Energy Systems Catapult, but we all try to work together anyway. We all have core funding from Innovate UK of £10 million a year. It's not a huge amount, and we're expected to use that £10 million to leverage in another £10 million from direct research funding from industry and a further £10 million from competitively won funding sources. We're all about collaboration. We've heard collaboration mentioned a lot today. I think that's a very good thing. We're all about collaboration and partnership. We've set up 2 advisory groups, an industry advisory group and a research advisory group. They meet 2 to 3 times a year to give us a high-level view of our industry, the offshore renewable energy industry, from their particular perspectives. Our industry advisory group has most of the big hitters involved, both the device manufacturers, the OEM, and developers and operators involved. And the great thing about that group is the kind of people we get turning up. We get CTOs and CEOs of even those large companies turning up at our meetings, and I think that shows real commitment. We have a research advisory group which has 11 academics, key academics in their field from 10 of the big universities around the UK, because we are a UK organisation. 10 of the biggest, most relevant UK institutions in our field. There's a lot, I should have said earlier, it's a very crowded landscape that we're in. We don't want to make it more complicated, we want to make it simpler. So we aim to be the single body that industry can come to access all of those other stakeholders, the Carbon Trust, EMEC Energy Innovation Centre, just to simplify things. So we have to play very nicely with some of these outfits that do some of the similar things that we try to do, but we try to put it all under one umbrella where we can. The idea about catapults is that they should become, this is what Innovate UK wants us to become, centres of deep expertise in their technological fields. Now, most of the other catapults that I mentioned are based around a fairly narrow technology group, which they're supposed to use to deal with a wide range of industries. We're slightly different in that we're focused on an industry, and that industry is underpinned by a huge range of technologies. There's simply no way that we can become expert in that wide range of technologies. So we've chosen 7 knowledge areas. And again, I'll read them out, so just in case you can't actually see them on the screen. So the 7 knowledge areas we've got are blades, drivetrains, electrical infrastructure, and that's everything that's offshore, so that's cables, substations, wind and ocean conditions, foundations and substructures, that includes the kind of geotech stuff, operations and maintenance, a very important factor, and installation and decommissioning. Decommissioning is often the bit of Cinderella technology. And we have cross-cutting activities that more or less any company has to deal with. Now, last summer, Catapult that was based in Glasgow merged with the Catapult that is now Narrock, or used to be Narrock in Blyth in Northumberland. And whereas the Catapult that was set up by Innovate UK in Glasgow was very much a knowledge-based organisation, what we acquired from NAREC, the National Renewable Energy Centre, when we merged, was a lot of pretty serious heavyweight kit, proper testing and demo kit. And so our knowledge areas now have to be mapped onto that kit to some extent. So, for instance, our blades knowledge area maps very easily onto the 2 blade test facilities that we have just outside Newcastle now. We have a 50-metre, these are for offshore wind turbine blades. We have a 50-metre blade test facility, but we also have a 100-metre blade test facility, which is the largest in the world at the moment. We also map our drivetrains knowledge area onto our capabilities in drivetrains. We have 2. Nautilus is our marine, our tidal turbine test rig. It's really aimed at the kind of 3-blade horizontal axis type of tidal turbine. That can test turbines up to 3 megawatts. And Fujin, rather, is our offshore wind drivetrain test facility, up to 15 megawatts. Again, the biggest available in the world at the moment. And our other, I won't go through the entire list, we don't have enough time. Probably can read some of it. The other thing we're very interested in is innovation per se. And we like to stimulate innovation in our industry, in the supply chain and in academia around it. And one of the ways we do this is through innovation challenges. We're close to industry. We're more close to industry than our equivalents in the rest of Europe, the likes of the Fraunhofer centres, the Carnot centres. We're very close to industry, so we feel we get a very clear view on what industry's technical problems are. And we can then articulate those technical problems in a way that the academia, other RTOs, and the supply chain, innovative companies, can understand from their perspective. And we do that by setting out innovation challenges, which we publish on our website. And companies who believe, or academics who believe that they can address those innovation challenges, those challenge statements with their own expertise, can put information into an expression of interest form that's on the website. Again, it's all based around the website. We will take those, go through a kind of due diligence, suitability assessment exercise with each of those expressions of interest. And what we're looking for is a project, an idea that we can add value to. We're not trying to displace the other support mechanisms that exist around the country. In particular, we're not a grant-giving body, so we're not going to come to a company with cash to help them develop their idea. Instead, what we'll look for are projects that we can partner with, collaborate with, where we can see value at the end of the development process in industry, and where we can also see how we can find packages of funding that can pay our client and ourselves to help develop that technology and take it through the various steps to get it out into market. So again, it's all about collaboration.
That's nearly 10 minutes, Paul.
Oh, bloody hell. Okay, so I'll very quickly run through the 3 case studies. This first one is an example of us convening industry around a particular topic that they've said they need addressing. Phase 1 started with a general scoping study. That brought up 6 work streams. We've worked through those now. Phase 2, we've actually got some results coming out from, particularly from the yield optimization project that we did. Those results, because this is for the whole industry, so they'll be published in full. They're for everybody to get value from. They'll be published on our website. We'll probably announce it on Twitter, so please follow us, sign up for our newsletter, or just keep checking on our website. This is an example of a project where we've convened it ourselves around one of our pieces of test kit. It's all about reliability and predicting reliability. Phase 1 will start by looking at what information's out there, in particular, what information is out there about real tidal turbine reliability problems, and also information, facts about what actual environment do these tidal turbines see. Phase 2 will be looking at any gaps we've got in that information, so we might have to go out and do some kind of a data gathering exercise on actual turbines in the water. Then we'll try and use that information to develop a software tool that will predict reliability, something that can be used to inform the design stage and also be used to inform the testing schedule that you can use to test a tidal turbine powertrain. And then phase 3 will be us disseminating that and looking at how we disseminate it, because if we spend a lot of our money developing this software tool, we're required by our Innovate UK funding rules to get some commensurate value from that investment. So we might have to license that software out. If it's fully grant funded, then we can make it open source. And if it's something somewhere in between, we might offer free licenses to the collaborators in this actual project, and then pay licenses outside. But the key thing is this needs to become an industry standard, accredited, certified piece of software that the whole industry can use in their design stage and in their testing stage.
I think those case studies would be really useful. Yeah, I think we're going to have to wrap it up there. But I was going to ask MEP, yeah, there's a lot of useful information in the presentation slides. I'm guessing they're going to be on the MEP website, are they? Okay, good stuff. Thanks, Paul. Sorry to cut you short.